Welcome to One and All Connected here. This is Dr.P.Saranya, Assistant Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Autonomous, Salem 16. In this video, we are going to see the topic about the plane. First, we see the introduction of the plane. Plane in geometry prolongs infinitely in two dimensions. It has no width. We can see an example of a plane in coordinate geometry. The coordinates define the position of points in a plane. In mathematics, a plane is a flat, two-dimensional surface that prolongs infinitely far. A plane is a two-dimensional analog that could consist of a point, a line, and three-dimensional space. Planes can appear as subspaces of a few higher dimensional spaces like the room walls extended exceptionally far away. These walls experience an independent existence on their own, as in the framework of Euclidean geometry. Next, we see some basic formulas. First, we see the general equation of a plane. The first degree equation in x, y, z, namely ax plus by plus cz plus d equal to 0, always represent a plane. Here, a, b and c are not all equal to 0. Next, equation of a plane passing through a point. If ax plus by plus cz plus d equal to 0 is a plane equation and it passes through a given point p of x1, y1, z1, then the required plane is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Equation of the plane making intercepts a, b, c on the coordinate axis is x by a plus y by b plus z by c equal to 1. Equation of the plane passing through 3 points a x1, y1, z1, b x2, y2, z2 and c x3, y3, z3 is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Equation of a plane in the normal form is x cos alpha plus y cos beta plus z cos gamma equal to rho, where rho is the length of the perpendicular from the origin on it and cos alpha, cos beta, cos gamma are the direction cosines of the perpendicular line. Length of the perpendicular from the origin O to the given plane ax plus by plus cz plus d, which is equal to 0, is given by rho equal to minus d divided by root of a square plus b square plus c square. Length of the perpendicular from the point P of x1, y1, z1 to the plane ax plus by plus cz plus d equal to 0 is given by rho, which is equal to plus or minus ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. Next, we see the formula for the plane through the intersection of two given planes. Here we consider plane 1 ax plus by plus cz plus d1 equal to 0 and plane 2 ax plus by plus cz plus d2 equal to 0 is ax plus by plus cz plus d1 plus k into ax plus by plus cz plus d2, which is equal to 0. This is the plane through the intersection of two given plane formula. Next, we see the formula for definition between two parallel planes. Here also similarly we consider plane 1 which is ax plus by plus cz plus d1 equal to 0 and plane 2 is ax plus by plus cz plus d2 equal to 0 is d, which is equal to modulus of d1 minus d2 divided by root of a square plus b square plus c square. Next, we see some example problems for the above formulas. First problem is find the equation of the plane passing through the point 2, minus 4, 5 and parallel to the plane 4x plus 2y minus 7z equal to 5. First, they given equation is 4x plus 2y minus 7z minus 5 equal to 0. Next, we see any plane which is parallel to equation 1 is of the form 4x plus 2y minus 7z minus 5 plus k equal to 0. Equation 2 passes through the point 2 comma minus 4 comma 5. So you have to substitute the point 2 comma minus 4 comma 5 in equation number 2. We get k value is 35. So you have to substitute the k value. The required plane equation is 4x plus 2y minus 7z plus 35. Next example is find the equation of the plane passing through the point 1 comma minus 2 comma 2 and minus 3 comma 1 comma minus 2 and perpendicular to the plane 2x plus y minus z plus 6 equal to 0. Let the required equation of the plane be a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Plane equation 1 which passes through the point 1 comma minus 2 comma 2. Therefore, you have to substitute the values in x1, y1 and z1. A into x minus x1 plus b into y plus 2 plus c into z minus 2 equal to 0. This is considered as an equation number 2. And then equation number 2 passes through the point minus 3 comma 1 comma minus 2. And you have to substitute this value in x, y, z. Therefore, a into minus 3 minus 1 plus b 1 plus 2 plus c into minus 2 which is equal to 0. We get minus 4a plus 3b minus 4c equal to 0. Now consider plane 2 is perpendicular to 2x plus y minus z plus 6 equal to 0. That is 2a plus b minus c equal to 0. We have to consider that is equation number 4. From equation number 3 and 4, we have to find the value for a, b, c by using cross multiplication. We get the value a is 1, b equal to minus 12, c equal to minus 10. Using these values in equation number 2, we get the final equation x minus 12y minus 10z minus 5 equal to 0. Next example is find the equation of the plane which passes through the points 1, 0, minus 1 and 2, 1, 1 and parallel to the line joining the points minus 2, 1, 3 and 5, 2, 0. Here the equation of a plane passing through a point x1, y1, z1 is a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Since this equation is passes through 1, 0, minus 1, you have to substitute the value x1, y1, z1. That is a into x minus 1 plus b into y minus 0 plus c into z plus 1 equal to 0. This equation number 1 passes through the point 2, 1, 1. A into 2 minus 1 plus b into 1 minus 0 plus c into 2. That is a plus b plus 2c equal to 0. Now we have to find out the direction ratios of the line joining the 2 points minus 2, 1, 3 and 5, 2, 0. The direction ratios of these 2 points is 7, 1, minus 3. Plane 1 is parallel to this line. Any normal of plane 1 is perpendicular to this line direction ratios of 7, 1, minus 3. That is therefore a1, a2 plus b1, b2 plus c1, c2 equal to 0. 7a plus b minus 3c equal to 0. Eliminating a, b and c from equation number 1, 2 and 3, we get the value for a is minus 5 and b which is equal to 17, c equal to minus 6. Substituting these values in equation number 1, finally we get minus 5x plus 17y minus 6z minus 1 equal to 0. This is the required equation of the plane. Next we see the another problem. for the equation of the plane. Find the equation of a plane through 1, minus 1, 2 and perpendicular to the planes 2x plus 3y minus 2z equal to 5 and x plus 2y minus 3z equal to a. Equation of a plane passing through 1, minus 1, 2 is a into x minus 1 plus b into y plus 1 plus c into z minus 2 equal to 0. And perpendicular to the line is 2x plus 3y and perpendicular to the plane is 2x plus 3y minus 2z equal to 5. That is 2a plus 3b minus 2c equal to 0. And another perpendicular plane is x plus 2y minus 3z equal to a. That is a plus 2b minus 3c equal to 0. Solving these three equations, finally we get minus 5x plus 4y plus z plus 7 equal to 0. This is the required plane equation. Next one. Find the equation of the plane passing through the points 2, 5, minus 3, minus 2, minus 3, 5 and 5, 3, 3. Equation of the plane passing through 3 points. We have to consider the points x1, y1, z1, x2, y2, z2 and x3, y3, z3. And the formula is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 equal to 0. Substitute these 3 points in this formula and solve this value. Solve this determinant. Finally, we get the required plane equation is 2x plus 3y plus 4y plus 4z minus 7 equal to 0 is the required plane equation. Show that the fair points 0, minus 1, minus 1, 4, 5, 1, 3, 9, 4 and minus 4, 4, 4 lie on your plane. Substitute the equation of a plane passing through the 3-point formula. We get determinant of x minus 0, y plus 1, z plus 1, 4, 6, 2, 3, 10, 5 which is equal to 0. We have to solve this determinant 5x minus 7y plus 11z plus 4 equal to 0. Now we have to prove the point minus 4, 4, 4 also lie on this plane. So we have to substitute this point in this equation 5x minus 7y plus 11z plus 4 equal to 0. Therefore, the given 4 point lies on 5x minus 7y plus 11z plus 4 equal to 0. Next problem is find the angle between the planes 2x plus 4y minus 6z equal to 11 and 3x plus 6y plus 5z plus 4 equal to 0. Angle between the two planes formula is cos theta which is equal to plus or minus a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square root of a2 square plus b2 square plus c2 square lies between the two planes 2x plus 4y minus 6z equal to 11 and 3x plus 6y plus 5z plus 4 equal to 0. Substitute these two plane values in this formula. Finally, we get cos theta which is equal to plus or minus 0. So, theta value is which is equal to pi by 2. Next, we see the distance between the two planes. So next question is find the distance between the planes x minus 2y plus 2z minus 8 equal to 0 and minus 3x plus 6y minus 5z equal to 57. Distance between two parallel planes formula is d equal to modulus of d1 minus d2 divided by root of a square plus b square plus c square. So here you have to substitute the values in this formula. Finally, we get the distance is 9. Thank you.